Discrete data are often used to provide the basis for a continuous function. For example, we may measure the thermal conductivity of a material at a few discrete temperatures and then develop a best fit curve or function that passes through these data that we then use to predict the thermal conductivity at any temperature within the measurement range. Curve fitting plotted data allows a dependent variable to be fit to a single independent variable, like this conductivity as a function of temperature example. Linear regression is discussed in a subsequent video, and this provides a technique for fitting a dependent variable to a function of several independent variables. Let's consider the data that's shown in this lookup table. The left column represents temperature and the right column represents measured thermal conductivity. We can use these data to create the plot that is shown here. We can use the data also to generate a curve fit. So any data that's plotted in ease can be used as the basis of the curve fit. And the way you do that is you select curve fit from the plots menu, and that accesses the curve fit plotted data dialog, which is shown here. The left window shows each of the data series that are contained in the plot. In this case there's only one, which is conductivity as a function of temperature. On the right side of the window here, you see that the user can select from a number of different mathematical forms or equations for the curve fit. The corresponding equation is then shown in the window at the bottom of the dialog. Each of these mathematical forms contains a set of unknown coefficients that will be adjusted so that the function matches the data using the linear least squares method. Here the equation that is selected is a second order polynomial. When the fit button is selected, ease will attempt to determine the best values of the undetermined coefficients in this equation. In this case, the variables a0, a1, and a2. The result is shown here. Notice that the equation has turned red and the unknown coefficients are now replaced by their best fit values. There are several useful options that you can select from in the dialog box at this point. The plot button causes the curve fit to be overlaid onto the plot so that you can visually see how well the best fit line matches the data. If the place equation on plot option is selected, then the curve fit equation itself is also placed on the plot. The copy equation to clipboard causes the equation to be placed in the clipboard so that it can then be pasted into the equations window or into another application. If you hit the stats button, that will bring up the curve fit statistics dialog that's shown here. The curve fit statistics dialog lists the value of each coefficient as well as the standard error associated with that coefficient. The RMS and the bias errors of the curve fit are also shown. The RMS error of a curve fit is computed according to this equation, where n is the number of data points, y sub I is the value of the dependent variable, and ym sub I is the value of the dependent variable that's estimated using the curve fit. The bias error is computed according to this equation. The RMS error in general provides an indication of the deviation between the curve fit and the data in either direction, while the bias error provides an indication of a more systematic over or underestimate associated with the curve fit. It is also possible to enter a custom equation form into the curve fit plotted data dialog. For example, you may want to curve fit the conductivity data to the equation that is shown here, where a0, a1, and a2 are coefficients that should be adjusted in order to minimize the difference between the data and the curve fit. Notice that this is not one of the standard equation forms that's available. Therefore, you must select the Enter Edit Equation button as shown here. Then you enter the equation using the appropriate names for the dependent and the independent variables, here temperature and conductivity. Any unknown coefficients that must be determined in order to complete the curve fit should be entered as a0, a1, etc. Once you have entered the equation, select Fit in order to bring up the dialog that's shown here, which allows you to enter guess values and limits on the unknown coefficients should you want to do that. Once you're done, select OK in order to obtain the best fit values for A0, A1, and A2. The result is shown here and used to create the plot that's shown here. Again, curve fitting is a powerful way of developing an equation or a model to discrete data points.